Using ratios and unit rates, Taylor and Anya live 63 miles apart. Sometimes on a Saturday, they ride their bikes toward each other's houses and meet somewhere in between. Taylor is a very consistent rider. She finds that her speed is always very close to 12.5 miles per hour. Anya rides more slowly than Taylor, but she is working out, and so she is becoming a faster rider as the weeks go by. So there are several different questions that we can ask about this situation, and I'm going to approach one at a time. So let's start with A. On a Saturday in July, the two friends set out on their bikes at 8 a.m. Taylor rides at 12.5 miles per hour, and Anya rides at 5.5 miles per hour. After 1 hour, how far apart will they be? So for part A, we have to look at Anya and Taylor separately and look at how they are moving, how many miles they have, and then we'll add them up and subtract them from the total of 63. So Taylor, we're told, is moving at 12.5 miles per hour. So that's 12.5 miles per hour. And if we multiply by 1 hour, the amount of time they are riding, the unit will cancel out, and that will show that she has gone 12.5 miles. Now, Anya's rate at this point in time is 5.5 miles per hour. So her mileage is going to depend on 5.5 miles per hour times 1 hour of time, the same amount of time Taylor was riding, which is going to show a distance after the unit hours cancel out of 5.5 miles. So together, if Taylor rode 12.5 miles and Anya rode 5.5 miles, that's going to equal a total of 18 miles that they've ridden. If we subtract that from the 63 miles they had total, 63 miles minus 18 miles is going to show that they are still 45 miles apart. So that is our answer to part A. How far are they apart? They're now 45 miles apart. Now B is asking to make a table to show how far apart the two friends are after 0 hours, 1 hour, 2 hours, and 3 hours. So if we set up a table for B, let's make our table comparing the amount of hours going by and then the distance that the girls are apart. Now they're going at the same rate as A, so in 0 hours before the time has started, we know they're 63 miles apart. Again, from the information in the original part, they're 63 miles apart. That's what we subtracted after the first hour from part A. We saw they are going to be 45 miles apart. Now we need to figure out after 2 hours and 3 hours. Well, from 63 to 45, we're subtracting 18 because that's the 18 miles that they went in 1 hour. Well, in another hour, it's like they're going to go another 18 miles. So if I take 45 minus 18, that will give me my next value of 27. I then can subtract another 18 for the third hour. 27 minus 18 will give me 9. So here is a table representing the hours going by and the distance, how the girls are getting closer and closer to each other. C is asking, at what time will the two friends meet? So we can see from the table, we can see in our rates from part A with our distance that these girls are moving 18 miles per hour together. Each hour they get 18 miles closer towards each other. So we can use the fact that that rate is going to be 18 miles per 1 hour. Well, we can see how many hours it will take to get 63 miles, since 63 is the total amount they have to go. So 18 to 63, or 63 divided by 18, is multiplying by a factor of 3.5. So if I multiply 1 hour by 3.5, that will give me that it will take, for 63 miles to travel, it will take them 3.5 hours. So that would be our answer for part C. Now we have part D. We have the same situation with Taylor and Anya. They still live 63 miles apart. But now part D is saying, if Taylor is saying, if I ride at 12.5 miles per hour towards you and you ride at 5.5 miles per hour toward me, it's the same as if you stay still and I ride at 18 miles per hour. That's her claim. What do you think Taylor means by this? And we have to say, well, whatever she means, is she even correct? So we kind of have to break this situation down. We have to see what she's saying. So what Taylor really means is that the distance between them is decreasing by that 18 miles per hour. That's how their distance is decreasing, 18 miles per hour, or for every hour. So the amount of time it will take them to meet is the same as if one person didn't move. So let's say Anya didn't move and then Taylor was going 18 miles per hour. It will still take them the same 3.5 hours to get to each other, or have a distance of 0. However, we just have to be careful, and it's important to note that the place that they will meet will not be the same. They're not going to meet somewhere in the middle. They will be meeting at the person who didn't move's house. So that's more of a thinking question about the situation, and thinking and comparing the rates and seeing if we can have them be similar. Now part E is finally asking, a couple months later on a Saturday in September, the two friends set out again on their bikes at 8 a.m. Taylor, as always, rides at 12.5 miles per hour, and this time they meet at 11 a.m. How fast was Anya riding at this time? Well, let's look. 11 a.m. minus 8 a.m., looking at the difference in time, is a total time of 3 hours. So she's definitely riding faster than she was, since it took 3.5 hours before, but that's just a note to realize. So if Taylor is riding at 12.5 miles per hour, she's riding at 12.5 miles per hour, that could be 12.5 miles equals 1 hour. Well, we can see how many miles she went in 3 hours, because that's the time it took her to get to Anya. So 1 hour to 3 hours, multiplying by 3. So we're going to multiply 12.5 by 3 to see that she went 37.5 miles in 3 hours. Still not answering the question, but we can use this information that if Taylor went 37.5 miles, we have to subtract that from our total of 63. So 63 minus 37.5 is going to be 25.5 miles left. That is the distance that Anya has to cover. So we're seeing that she is going to cover 25.5 miles in a time of 3 hours. If we want to find her rate, her unit rate, how fast she was traveling, we can divide the top and bottom, the numerator and denominator, by 3 to equal 8.5 miles in 1 hour. So she was traveling 8.5 miles per hour. That would be her rate of speed, how fast she was going.